parts of this course. When we look at distance, so we talked about scalar and vector quantity. Scalar quantity has magnitude and units. A vector quantity has magnitude, units, and direction. So displacement and distance are the first two that we focus on, and then they lead into speed and velocity. My best example that I use is I start as we go right here. Rollin is right here. I travel to Yorkton, 80 kilometers from Rollin to Yorkton. So if I ask you what the distance is, what's the distance traveled? 80 kilometers. So that's it. And normally we would change that into SI units, but right now we're going to leave it as is. Now if I ask you, what is the displacement?
80 kilometers. 80 kilometers south or whatever direction.
West.
What is it?
West.
80 kilometers, and then you have to add west to it. Okay, so far so good. All right, now let's say I go to Yorkton and I come back to Rollin. What is my distance traveled? 160 kilometers. What is my displacement?
0.
What is it?
0 kilometers more.
All right, so I heard 80 and I heard 0 and I heard 160. So how do I calculate what my displacement is? My displacement, what does that triangle mean?
Change.
Delta, which means what? Change. And how do I represent change within an equation? Any idea? Okay. We take our final displacement and we minus our initial displacement.
Oh, yeah, we did that.
So our final displacement minus our initial displacement. Well, our final displacement is at 0. And our initial displacement was at 0 as well. So therefore, my displacement total for this trip is 0 kilometers. Make sense? Okay. Now, if I make this trip, and let's say I stop at the McNutt Corner, which is 20 kilometers from Rollin. So I've gone to Yorkton, I've traveled partway back to the McNutt Corner, and then I stop. What was my total distance traveled?
140.
100 what?
140, right?
Just 100.
Oh no, just 100. No, just 140. Because it's 20 kilometers from Rollin, right?
Yep.
So it'd be 140.
140. So we went 80 this way and 60 back?
Oh, so they stopped?
That's right.
Yeah.
So we stopped at the McNutt Corner for a second. So that's 140 kilometers. So that's my distance traveled. What is my displacement?
1 kilometers.
West.
20.
20 kilometers west.
20 kilometers to the west. Okay? Because that's where I'm located. I'm right here. This is 20 kilometers to the west of where I started right here. So I take 20 and I subtract 0, but I designate it as the west as a positive direction for this question. So that's my displacement. We following so far?
So what if you went?
Okay, just 1 second. I'm going to change the question. Maybe this will answer your question. Okay? So now, let's say I go from Rollin to Yorkton. I couldn't get the part I wanted in Yorkton, so I come back to Rollin, and I phone Grandview, and Grandview has it. Because that would probably happen. So I go all the way to Grandview, and it's 53 kilometers in that direction. So now, what is my total distance traveled?
233.
200 and... 200.
No, 33. Isn't it? 30. Yeah, 33.
53 on 160.
Oh, sorry, I was thinking 180. My bad. Yeah, that's 13.
So 213 kilometers, that's right. So you got that right. Distance, 213 kilometers. Displacement, then is what?
53 kilometers east.
That's right, 53 kilometers east. So you guys got this down.
Yeah, we did a lot with this last year.
You did. Okay, and that's important that we do all this. All right, so now let's continue on with our question. And let's look at this in terms of my velocity and my speed now. So speed, by definition, is your total distance over your, I call it change in time, but basically it's your elapsed time. So let's say it took me 2 hours to make this trip from Roblin to Yorkton and then back to Roblin again. So what was my average speed? What was the total distance I traveled to go from Roblin to Yorkton and back to Roblin? 160. And I said it happened in 2 hours. So what is my average speed for the trip?
80 miles per hour.
80 kilometers per hour. Okay, so now what happens if I go from Roblin to Yorkton? I do it in an hour. What is my velocity?
No, I can't tell you.
What is my velocity? Well, my velocity is my total displacement. Not my total. I don't talk about it as a total. It's my displacement over my time. So where is Yorkton related compared to Roblin?
80 kilometers west.
80 kilometers west. And how long did I say it took me to get there?
Well, an hour. Because it took you an hour, 2 hours to get.
Yeah, so I did say an hour though, right? So my average velocity in this case is 80 kilometers an hour to the west. What about if I look at my average velocity if I went from Roblin to Yorkton back to Roblin in 2 hours? What is my average velocity?
40 kilometers an hour west.
No. Is it?
I'm going, so I need to look at, okay, let's work with this. I'm looking at my displacement. So I went from Roblin to Yorkton back to Roblin. What's my displacement?
0.
0. Yes, I do. I have to subtract. You're right. So what is it?
0.
It's 0. So therefore, what would my velocity be?
0 kilometers an hour.
0 kilometers an hour. Makes sense so far?
Yeah.
Okay, so far we're okay? And again, like you said, you've done some of this already. All right, that's great. Now, what we tend to do, or what I tend to do, is when I teach, when it comes to directions, I look at just my normal math grid, and I treat the directions and their plus minus is in the same way I would on this grid. If you look at the grid right now, the north is all the positives, right? And the south is all the negatives. So generally when I do work with north and south, I will almost always make, if not always, make north as my positive direction and south as my negative. And if I look at this grid, I look at east as being positive because the right side of a graph is positive and the left side of the graph, west, is negative. So I treat them as east and west. East is positive and west is negative. Now that becomes important to us if I were saying, okay, well, what is my displacement if somebody traveled 15 kilometers west to begin with, so it goes somewhere over to here, and then travels 30 kilometers to the east after the fact. So then I end up somewhere out here, okay? And I say, okay, well, what's my displacement?
15
Now-
kilometers.
Now, excuse me. Okay, so how do we do this question?
30, take away 15.
30 take away 15?
Pretty much, yeah.
Pretty much? Yeah, that works for this.
Not all
But-
of them.
What I'm doing though is, why did I decide on a negative here? Well, what I do here, and this is, the reason I show you this is because we're going to get into vectors in the next 2 units from now. And vectors is all about direction and drawing arrows in the positive and the negative direction. So it's important that we kind of pick up on the little things right now, it'll make that a lot easier. So basically, if I were to add 30 kilometers to the east and 15 kilometers to the west, it doesn't work so well because I'm not going in the same direction, so I don't want to add them. I know that I have to subtract them. So what I do is I simply do this. I make that a negative east direction. What's a negative east? Well, that is the same as west. Okay? So for adding purposes, I like to make sure that my directions are the same to add them together. So if it's a west direction, I would make it a negative and change it to east. Now I can actually add these together, and Brock's right. I would end up being 15 kilometers east of where I started. Okay? So I can't add east and west together because they're not going in the same direction. But then when we get into vectors, now we start throwing in arrows in multiple directions. So northeast, southwest, southeast. So we start throwing those in. So we want to get this very basic step right now, and then that makes it a lot easier.
So what happens, say you do that, and then you go up 40 kilometers. Like you start where you go to there.
Yeah, so right now, all we're going to do is work in east-west or north-south. We're not going to go east and then north yet. That comes into chapter 3. Okay, that's when we get into vectors and we have to draw them. So for right now, we are just going to simply work with east-west, north-south, not combine those together. Okay? So it makes it a little more simple direction. Yeah. Okay, so back to what I'm saying here. One of the most important things that we forget, that students have a hard time remembering, is when I ask you for average, let me do that again. When I ask you for average velocity, okay? When I ask you for average velocity, I am asking you for your change in displacement over your change in your time. So if I put you in multiple directions, if we go in multiple directions, okay, the main thing that you have to do is find your change in your displacement and divide it by your change in your time. Okay, you have to understand. If you're looking for average speed, you just simply take your total distance that you traveled and divide it by the total time traveled. But we don't work with speed, we work with velocity. Because velocity also has direction to it. So we have to make sure that we work with velocity more than we work with speed. Okay? How are we doing so far?
Good.
Okay so far?
Um,
All right. Go ahead, Austin.
we have like S, that's our symbol for speed, and V is for velocity.
Yeah.
Last year we had V for speed and velocity. Now
You
it's
can, I don't like it, but you can. I'm okay with that, but here's what I do. Here's the difference. If you're going to use V as a speed, like as your speed unit, then you got to make sure that your velocity unit has an arrow over it.
but S would be better.
S is fine. Okay. All right, and it's easier to remember too. Yes.
Could you do a question for us on like average velocity?
Yeah, I'm gonna tie it all in here right away. Okay. I got one more thing I want to show you about this. Okay. Now, everybody's following so far. Change in D over change in T, because this is going to be hugely important. We're going to get into some graphing now. Okay. So we're going to watch this.
They seem
Groaning?
enthusiastic.
Groaning about graphing. Oh, this is easy. So, and watch how easy it is. Okay. On a graph, what you know so far, what axis is this? It's your y-axis, right? And what axis is this?
W.
All right, so there you go. You got your x and you got your y. Some would say w. They'd be wrong, but that's what we got. Okay, so I have a line now. Okay, I have a line. I have two coordinates. This coordinate right here is going to represent my x1, you don't have to draw this out. I don't need you to draw it out. I just want you to watch. And then that's y1, right? x1 and y1. So my coordinate, if I were to write my coordinates out, it's x1, y1, just like that. We all agree? Okay, it's pretty straightforward. That's where the line starts. So where the line ends then, where are my coordinates where my line ends?
X2 and Y2.
X2 and Y2. Excellent. So if I asked you then, I want to find the slope of this line. You guys remember what slope is?
Yep. Rise over run.
Rise over run, right? So the slope is rise over run. And if I'm looking at my graph,
Y2 take away Y1.
it's the change in my y over the change in my x, right? So far so good? So y2 minus y1, and then we shorten it and we write it as change in y over change in x. That's what slope is equal to. And I make m as my slope, right?
Yeah.
Remember that from grade 10 math, right? So I've got m is equal to change in y over change in x. Everybody okay with that so far? Yeah, I feel like I'm doing a magic trick and I'm trying to get you to follow along here. Okay? But here's the thing. What if I do this? All right? What if I change my y and I say that my y-axis is going to represent the displacement I traveled? Okay? So the y-axis is going to be the displacement I traveled. So this is going to tell how far I get. Now I'll show you an example as to how that works in a second. But this is going to be my displacement. That's what my axis is. Remember, I can label this axis anything I want, right?
Yeah.
But this axis is the dependent variable. Okay, that's the dependent variable. We've done that, right? And then the bottom one is always my independent, is the one that I don't really control all that well, where it just keeps going. But in this case, it's the one I alter. Well, it's my time, right? So I have displacement on the y-axis and time along the bottom axis. We all agree? Okay. So I may want to change this then. So instead of x1, y1, I'm going to make that, I'm going to change colors. That time 1, d1. That's my x and my y, right? And then over here, I'm going to go time 2, d2.
So then it would be
So far, so good?
D2 take away D1 over D2 take away
Right. So I'd have d2 subtract d1 over t2 subtract t1, right?
and that would get you your velocity.
So that would be change in displacement over change in time. Right? d2 subtract d1 over t2 subtract t1. We all agree?
So what if there's more?
So what is that? That is my velocity. So from this graph then, I'll answer your question in a second. From this graph, if I find the slope of the line on this graph, what have I just found?
Velocity.
I found my average velocity.
Not true.
So now, you want to ask your question?
Yeah.
Okay.
What happens if there's more than 2 points on the line? Like, is that
The
line?
slope still won't change. If it's on that line, it doesn't matter where you take the values from, your slope stays the same.
Can you still do it if the line starts decreasing?
Yes.
Yeah.
So I'm going to show you how this works right now. Okay, we're ready to watch how this is going to make sense, a little more sense to you? All right. So my initial question was, or my initial example was, we are going to go, so this is my displacement over here. My time is down here. All right. We turn off a hospital street. Okay, so we're turning off a hospital street and we're going towards Yorkton. So as I'm moving towards Yorkton, I'm speeding up, and just past Roblin Ford, I hit the 100-kilometer sign, right? 100-kilometer-an-hour sign, correct? So I'm going to gradually speed up until I hit 100 kilometers per hour. Then I may set my cruise control. So I'm going to set it on 100. And then as I get into Yorkton, it starts to slow down until I hit the first set of lights, and the light's red. So I'm going to hit the set of lights, I'm gonna slow down until I get to the point where I actually stop. Okay? So, as this trip is occurring, I'm getting further and further away from Roblin, correct? All right? So, I kind of messed this up a bit, but anyways, this is how it's going to look. So, I'm going to I kind of botched this example, but let me see. Hold on, let me think this through. I want to do this so I make it make sense to you a little bit better. So I'm going to, I was thinking of increasing my speed. No, this works. Okay. Not really. Shoot, I could have used this example better if I was using velocity and time rather than displacement and time. So,
You walk somewhere.
just a second. Okay, I gotta figure this out. Okay, let's scrap that example. I'm gonna come back to that example when I do it velocity and time. It works way better for velocity and time. Okay, so let's look at a different example now. Okay. All right, let's do a different example. Sorry, the example I'll show you, I'm going to come back to when we get to the velocity time because it's
Because
going
you
to make
can't
a little
go
more
down
sense.
when we do it.
No, you can't. You absolutely can't. And I got to show you that too. All right, so let's do this a little bit different. Let's look at it as if, okay, I'm going to go to the fire hall. I get to the fire hall. I stop for a second because I think I forgot my phone at school because that's what you do. So you stop and you look in the backpack, see if the phone's not there, and now I'm going to come back to the school and grab my phone. Fair enough? Okay, so start out the front door, okay? And as I leave the front door, I am moving away from the school, right? So as that's occurring, this is the distance, or the displacement, sorry. This is the displacement that I'm getting at away from the actual school. This is how I'm getting away. So I get moving, and let's say that I get, what would that be? Maybe 100 meters. Doesn't matter, hypothetically. Excuse me. Thank you. So I get 100 meters from the school. I'm walking cross country right to the fire hall. So I get to the fire hall and I stop. I'm like, oh, my phone's not here. It's not in my pocket. So I stop. So what happens? Does the time stop? My time keeps going. But I do not. I don't.
You don't know.
So
I don't move.
that's a dead stop.
So that's at a stop, right? Because time's moving, my distance is not. My displacement's not changing. Now I remember. Oh shoot, it's probably in my locker. So what happens? I now
Walk down and run back.
go back very quickly because I need my phone. So I don't want to be late for work. So I'm running. So notice the steepness of that line, right? What that shows is if I look at the slope of that line,
Go fast.
I'm going faster. But if you actually find the slope of that line, it's going to be
Negative.
a negative value. So what does the negative value in velocity show?
You're going south.
Change in direction. Yes. If I said that the fire hall was north, which it is, it's north of us, okay?
East.
It is northeast of us, yeah. But if I showed it in that sense, then that would mean that I'm going back in the opposite direction, back towards the school is. Got it? Does that make sense to everybody so far? Okay. Now, if I find the slope of this line from here to here, I would then get what my average velocity is for the start of that trip. What's my average velocity on this part of the trip?
Zero.
Zero, because my displacement is
Zero.
zero. Time's still moving, displacement is not. Fair enough? Okay, let's look at an example in the book that describes all of this. So one of the things that you need to do, so take out a piece of paper right now. Take out a piece of paper.
Yes.
No.
Chilly enough in here?
Yep.
There's-
If you want, you can.
Hold
open
on.
it.
No, I'm good.
Yeah.
That makes sense.
All right, so I have 6 sections to this graph on page 49.
Oh, 49.
49.
Mhm.
Okay, so in A, the time across the bottom is in seconds, okay? And the displacement up the side is in meters. So in A, how far did I go in 2 seconds? 6 meters. So what I want you to do on that piece of paper is create this chart. And I want you to write in there 6 meters and 2 seconds. All right? So write this out on the chart. Now, the reason I'm having you do this, even though it's in the book, is because this is how you're going to set it up on your test. All right? You're going to have to set up the chart just as is. So we want to get used to that now. In B, what's the displacement in B? 0. And how much time were they stopped for?
4 seconds.
4 seconds. Okay, great. In C, what is the displacement in C?
-16. Right?
How do you get that?
That's what it says.
I'm looking at the graph.
You went
Don't look at your
down
chart.
6 and then down 10.
Okay, so that's one way to look at it, Amrit. You're right. You're going 6 back to where you started and then 10 away from that spot. Okay? But the right way to do that is to go -10. That's your D2, right? Subtract your D1, which is 6. Okay? Because you started 6 meters away on the plus, and you ended up 10 meters on the other side. So it's -16 meters. And how long did it take you to get 16 meters?
4
4 seconds. And then what happens in D?
Stop again.
Stop again
For 2 seconds.
for 2 seconds. And then E,
In 1 second, you go 6 meters.
in 1 second, you go 6 meters. Is that in the positive direction or the negative?
Positive.
You sure?
Yes?
Okay.
No?
All right. What do we designate as going in the positive direction in this graph? Up or down, above the line or below the line? No.
Just going up.
Just going up. So in that case, we are going back towards where we started, but that is in the positive direction.
Okay.
Okay, so that's right. And then in E, we go 4 meters, because then we go back to where we started. Right? And how long did that take? 4.5 seconds?
Yes.
Okay. Okay, so now what we want to do is let's calculate what our change in velocity is for all of them. All right? Okay, so in A, what is it?
3 meters per second.
3 meters per second. B,
0 meters per second.
C,
Negative 4 meters.
-4 meters per second. So what does that mean again?
You're going down.
Going in the opposite direction that what you initially were going in. Okay? Then I have 0 meters per second. Then I have 6 meters per second. And then I have 8.9
Yes.
meters per second. Awesome.
No, wasn't 4.5 seconds.
Because you're going from 13.
13 to 17.
They're saying that it's beyond 17, that's why. Sorry. It's not very legible, but that's what they're saying, is it's going beyond 17.
You can see it's past half, guys.
Okay?
Yeah, but that's
Yeah.
tricky.
Okay. Okay, now, the $1 million question. The one that sets you apart. You gotta figure out right now,
Average speed.
How to graph.
average speed first,
Oh.
average velocity second. So let's do that. I want my average speed. And I want my average velocity. Okay. Look back to what I wrote down earlier. I told you how to get average speed. I told you how to get average velocity.
Isn't that the average speed?
What do you think the average speed is, Brock?
I thought it's going
For the whole
to something some board says, oh no, that's displacement.
Then does the airplane end up actually starting?
The average speed is 1.83 meters per second.
1.83 meters per second? Okay, how did you get it?
I added up total distance and then I divided by the total.
What did you get as your total distance?
Let me just check that.
32, right?
Yes, that's what it was.
You got 32?
Isn't it zero?
No, that's displacement. Your distance
Oh,
you
yeah.
count, right? Because speed is no direction. It's just your distance time. Velocity is displacement.
Okay.
The velocity?
How, who got 32 for your distance?
I just did both.
Okay,
Betcha.
who's not sure? Okay, just look at my graph for a second. Just look at the graph. Don't look at any of the numbers on the board, look at the graph. How far did I go away in the positive direction? I went 6 meters away, right?
Mhm.
And then eventually I came back to where I started, correct?
Yeah.
So that's a total of how much distance?
12 meters.
12 meters, right? And then I went how many in the negative direction?
10 more meters.
10 more in the negative? And then did I end up back where I started?
You did.
So that's another 20?
Yeah.
So my total distance traveled then was
32 meters.
32 meters. You follow that? Brock, you don't follow that?
Not really.
Okay, look at your graph, Brock. Just look at the graph, top of the page, Brock. Okay? In position A, you go from 0 to 6 meters away from yourself. In position C, when it crosses back across the axis, the x-axis,
Yeah.
you come back to where you started, right?
Yeah.
So at this point, I've gone 6 meters away this way, and I've come back to where I started right here. So what's that total distance then? So 6 away, and then 6 back. Well,
Oh, yeah.
it's like walk 12 meters, right? Go from here to here, I walk 12 meters, right? Now I walk 10 meters this way, and then 10 meters back. So that's 12 this way, 10 this way, and 10 this way, so that's every 30. Right. Okay, so what was the total time that this trip took?
17.5 seconds.
17 and a half seconds is what we have, right?
That's correct.
So now we divide those two, and what do I end up with?
1.83 meters per second.
8.83 meters per second. All right. Displacement over time. What is my average velocity?
0.
0. That's right. 0 meters per second. How come?
So you ended it back where you started.
Because I ended up where I started from. Okay? We okay? Because I gotta move on. So I wanna make sure you're good. Alright? Okay. Now, same philosophy. that we just used to find my average velocity here, my average speed. We're going to do it using a sampled question now. Okay, in which we don't actually see the graph in front of us. We have to write out the information and design, get a visual in our own mind. A person walks 5 kilometers towards the east in 2 hours, then 1.5 kilometers towards the west in half an hour, and finally 10 kilometers towards the east again in 2.25 hours. What is a person's average velocity? Okay, this is at the top of page 51. All right.
Do we draw it out or not?
Well, what I would do, and this is what I was going to get to, is the best way to approach this is to draw a number line. A number line will help you get a better visual of it. So start like this, okay? West is over here, east is over here. I start in the middle right here on 0. Okay? So I walk 5 kilometers towards the east. So I'm right there to begin with. I'm going to ignore time for a second, okay? Then I walk 1.5 kilometers towards the west. What is that point right there now?
4 kilometers.
3.5.
Oh, 1.5.
3.5 in which direction from where I started?
East.
Right. I want to make sure I know that. Okay? So now, after stage 1, I was 5 kilometers to the east of where I started, right? After the second part of the walk, I'm now 3.5 kilometers east of where I started. Okay? And then finally, he walks 10 kilometers towards the east again. So now he walks another 10K, and this time, this way. So where is he from where he started?
13.5 kilometers.
13.5 kilometers to the east of where he started. Good job. That's right. Okay? How long did the whole trip take?
Ooh, that's a good question.
2 hours.
4.75 hours.
4.75 hours. Okay. First thing I want you to find now is the speed. I want to know what was the average speed. Calculate my average speed.
Should we be changing that 0.75 hours into minutes?
Okay. What's the first thing I need to do in order to find average speed? Total distance. And what was the total distance?
16.5.
16.5 kilometers? Anybody not know how I got 16.5 kilometers? So you went 5, and then 1.5, and then 10, right? Okay, and then how many hours did it take? 4.75 hours. And when you divide the two, what do I end up with?
3.47.
3 decimal places.
474.
474 kilometers per hour. Do I need a direction on that guy?
No.
No, because it's distance. That's right. All right. So now what I want is my average velocity. My average velocity. Where am I from where I started?
Okay, I was looking.
Okay? What do we get?
2.842 kilometers per hour.
East.
Good job. And you added the east at the end, because that's where I am. Good. Well done. Questions about that? Okay, pretty straightforward so far.
We can just put our east at the end, or do that have to?
Yeah, always at the end. In square brackets too. You always put your directions in square brackets, okay? We're okay with this one? All right, let's look at the second one then. This one is a north-south question, so I'm going to draw my line. Now you could draw it horizontally, and I'd be perfectly okay with that as well. That's all right by me, but I like visuals that make sense, so I'm going to draw a vertical one this time. So north-south. A car is driven for 1 hour with a velocity of 100 kilometers an hour towards the south. Then for 0.5 hours, the velocity of 50 kilometers an hour towards the north. And finally, 0.75 hours with a velocity of 80 kilometers an hour towards the south again. Find the car's average velocity. All right. This question right here is the be-all, end-all question. This is the one that if you can catch on to it, you don't have a problem in this section. If you can figure this guy out, you won't have an issue with this one. So,
Try ourselves.
no, let's talk about it. What is it? What's been given to you?
Time, distance.
Time and
displacement.
time and speed or velocity, actually, because velocity, right? Because we have direction. So we've been given the time and the velocity. But in order to find average velocity, what do I need to know?
Our
Change
time.
Change in displacement over change in time. So I need to find the displacement in each one of those intervals. The natural thing for a student to do is to calculate based on averages, add them all together and divide by 3. You cannot do that in this case.
Oh.
So you have to find the displacement in each. All right, my favorite question to ask. 100 kilometers an hour for 1 hour. How far did you go?
100 kilometers.
So they went 100 kilometers to the south. So my displacement in the first one was 100 kilometers to the south. Then you went a half an hour at 50 kilometers an hour.
25 kilometers.
25 kilometers
North.
to the north,
And then 60 kilometers to the south again.
and then 80 kilometers an hour for 3/4 of an hour, 60 kilometers to the south. Now, just put your pencils down for 1 second. Without using my visual here, I'm going to approach this question a little different. I'm going to do it the way I had showed you previous. Okay? I'm going to add the souths together, and I'm going to subtract the north. Or I'm just going to say, like, look, I've got a south here and a south here, but I got a north here. So what can I do?
Negative south.
Negative south, that's exactly correct. So now I add all 3 numbers together. So now I have 100, add negative 25, add 60.
135.
So what is it?
145.
145?
30.
135.
135, yeah.
Change in velocity or my average velocity. So there's how I write average velocity. That's EVG right there. 135 kilometers in which direction? South.
Divided by 2.25.
2.25 hours.
60
That's my
kilometers
total.
per hour.
What does it equal?
60 kilometers an hour.
60 kilometers per hour. So that's about as difficult as it's going to get in this first little part here. Okay? Before we get into actually all the formulas and stuff, that's as tough as it's going to get. And it's not difficult, it's remembering that you have to find the displacement totals, in order to get your average velocity.
That's fine.
Okay? We all right so far?
So velocity is really just the same thing as speed and direction.
Well,
Like the
last question was just
equation.
zero.
if you went in,
equation.
okay, but here's the thing, Brock. You went in a straight line and you never went anywhere else.
Yeah.
So like, for instance, if I go from here to Yorkton,
Yeah.
my velocity and my speed are gonna have the same magnitude.
But if you came back, then
But if I come back, then that's when the velocity changes. Okay? All right, so what you have today is you're gonna go back and you're gonna do the practice problems. So page 45, 46, and 52.
45, 46, and 52.
That's right. Okay? You have the remainder today to do that. It shouldn't take you very long.